A very good morning, students. We are in our practical lecture, and this will be lecture number 8. And today we are going to solve map number 11. And here is the question. A thin coal seam outcrop at three different altitudes, that is 60 meter, 50 meter, and 20 meter respectively. Trace the outcrop, describe the topography of the area, comment on the trend of the outcrop. Okay, so the question is quite different from the earlier one, right? So you have uh, same kind of outcrop in three different locations, that is in three different heights. Okay, so we used to call it as a 3 point problem which means we have to solve only with this 3 points. That is why we are used to call it as 3 point problem. Okay, so you have a point A which is at 50 meter, and you have a point B which is at 60 meter, and you have point C that is at 20 meter. So to solve this, what we have to do is we have to connect the top and bottom, or that is the highest and lowest contour values. See, as you remember the point that when there is an outcrop at a fixed altitude, there will be a strike of the same value. Is that right? Okay. So you have an outcrop here at altitude of 60 meter. So there will be a strike passing here with a value of 60. Okay. So likewise here will be a strike which is of say 20 meter, and there will be a strike of 50 meter here, right? So if you are connecting from 60 to 20, what we have, the distance will be like 50, 40, 30 and 20, right? So what we have to do is we have to measure the distance and divide by 4, and whatever the answer we are getting, we have to mark it like, say this is 60, so next point will be 50, then there will be 40, then again there will be 30, and 20 is already there. Okay, so you have 50 here and the same 50 in this side also. So we can connect these 2 points to draw the strike, that is the line connecting equal heights, right? So likewise we have to do. So what we have to do is the first step is we have to connect the highest and lowest contour, which is say 60 and 20. Then we have to do a calculation, that is the distance between the outcrop appears at higher contour and the lower contour divided by the difference in the contour into contour interval. So the distance between the higher contour and lower contour is say 9.8 centimeters, right? And the difference in the contour is say 40, which is 650, 40, 30, 20. There are four divisions, right? Into we have a contour interval which is 10 meter, as we have to follow the contour interval as your strike interval, so we are adding this, that is into 10. So what we are getting is 2.45 centimeter. So that is the horizontal equivalent in this line, not in any other line, right? So this will be differ from the actual horizontal equivalent between the strikes. So this is not the actual true dip, okay, but we have to check whether it is or not, but this may not be probably the true dip, so we cannot take this value for the true dip calculation. For time being, what we can use this value only for drawing the strikes. Okay, so we have to place the points at 2.45 centimeters along B to C. So you will be having say 1 here, 2 here, 3, then fourth one will be here. So if this is 60, then this will be 50, then again there will be 40, then there is 30, and 20 is here. So we have different set of values here, but we have the same 50 value in this side also. So what we can do is we can connect this 50 and this 50 to mark the very first strike. Okay, so this is the primary strike or first strike, what we can call. So after drawing this strike, we have horizontal equivalent, we have outcrop points here and equivalent values here. So what we can do is we can draw parallel lines, as you know, strike or parallel to each other, right? So we can use two set of set squares, and we have to draw parallel lines from this. So you'll be having a B point there, then there is other outcrop, then there is something else there, and the last value will be right here. So likewise we can use the two set squares and draw equivalent horizontal lines, right? These are the lines. And after that, as you do regularly, we have to mention the strike values, right? So the first one will be 60, and the next one will be 50, and you know this will be the dip direction. So 60, 50, 40, 30, and 20. So after this, what we have to do? We have to point the equal value of strike and contour. In the first case, you have 60 here and there is outcrop here. So you can make a point here which is 60, and the second line, the 50 is already marked, and here you can mark the second 50. And for 40 we have only one value, second 40 is not actually touching here. Then there is 30, you can place a point here, and 20 which is already marked. So we had marked all the values of equal value of strike and contour, and that's it. What we have to do is we have to draw the outcrop, which will be somewhat like this. Okay, and we had completed the strike. So what is the next step? Okay, after completing this, what we have to do is we have to mention the strike direction and dip direction, and for that we used to do parallel line from the north, right, for the measurement of strike and dip, and that's what we are doing right now. So we'll be drawing a line here, which is the indicator of true north. Okay. Then we can use a protector here to measure the strike direction. So you can see this is north and this side will be the west, and we are not reaching the 90. We are somewhere above the 90, which will be say 88, right? So the first question, that is the strike direction is north 88 west, and as you know, strike is bidirectional. So if this side, if it is 88, then you can expect this side will be 92. As it is a straight line, you will be having a 180-degree relationship, right? So the strike line is a straight line, so you have 180-degree relationship. So 88 is here, so this will be 92 east. So this is the strike direction. Then the dip direction, which is say 60, 50, 40, right? So this is the dip direction. So if the relation between the strike and dip, if it is say north 92 east, then we have to add 90 in this side. As you know, the relation between strike and dip is 90-degree. So that will be north 182 east. That is the true dip direction. Okay. So we have marked the true dip direction, and we have to mention the true dip amount. That is dip is equal to strike interval by horizontal equivalent to scale. Right? You remember, right? The strike interval is 10 here, and the horizontal equivalent is here is 2.2 centimeter, which I converted into meter. That is say 0.022 centimeter meter into the scale, that is 1 centimeter is equal to 20 meter. That will be 1 by 2000. So just dividing by this value, what you will get is theta is equal to tan inverse of 0.22. That will be 12.4 degree. Okay. So this is the dip direction, dip amount. That's it. So we had solved a map. In this case here we used three different altitude of a same outcrop, and we had completed it, right? So these are the possible sets of probabilities to get the questions. So far we have covered almost 11 maps, right? So in the earlier case, what we did is we got some dip direction and strike directions, right? And some outcrops say at one place or something. So by using that we had solved the alien maps. Then we got two outcrop or something. Then we have 3 to 4 bits, right? So now we are getting same outcrop appearing at 3 different points, which is called as 3 point problem. That also we have solved. Okay. If you have any doubt, just mention in the comment section. We will try to solve it in the next class. And for this will be over. Thank you.